Scientists studying the Milky Way have discovered a new rocky exoplanet, much larger than the Earth. Here's what they found up there. A super-Earth orbiting a red dwarf star has been discovered only 36 light-years from Earth, according to a study published in the Astronomy and Astrophysics journal. In a February 18th preprint version of the study available on the arXiv server, the planet's temperature is estimated to be around 556 degrees Celsius. Known as GJ740b, the planet has a mass believed to be around 3 times that of Earth and a diameter 1.4 times that of Earth's. The super-Earth orbits its star, known as GJ740, in just 2.4 days. Its mass and orbital period suggest it is a rocky planet. The data indicate a second planet may be orbiting the same star. It is believed to have a similar mass to Saturn and an orbital period estimated to be 9 years. GJ940b lies in the constellation of Serpens. The Astronomy and Astrophysics study identifies 2 methods for discovering new planets outside of Earth's solar system. The transit method involves examining variations in the amount of light received from a star caused by a planet passing between it and its observer. The radial velocity method involves examining a change in the color of the light around a star caused by the pool of planets around it. Space.com explains that red dwarf stars burn at a lower temperature than our Sun because their mass is between 7.5 and 50% less than it. Dimmer, as a result of this, it is easier to observe orbiting planets around red dwarfs, hence studies like this one. If this new exoplanet exercised your imagination, there are a lot more out there, so why not stick around and check out some of these other distant planetary discoveries.
Mascara 2b is a giant planet so hot that you can find vaporized metals in its atmosphere. This planet is so hot, it falls under a group of celestial bodies called hot Jupiters. Here's what experts discovered while observing Mascara 2b. Using the Extreme Precision Spectrometer, or EXPRESS, a team of multinational scientists were able to look more closely into the environment of Mascara 2b, a large, scorching hot gaseous planet in our galaxy, Yale News reports. Mascara 2b is a gas giant twice the size of Jupiter located 140 parsecs away from Earth. That's the equivalent of 4.3 quadrillion kilometers or 2.68 quadrillion miles. Mascara 2b is just 8 million kilometers or 5 million miles away from its sun, making its atmosphere reach temperatures of more than 1,726.6 degrees Celsius or 3,140 degrees Fahrenheit. Further observations using the EXPRESS spectrogram indicate that the gas giant contains small quantities of gaseous iron, magnesium, and chromium. But why would scientists want to study a planet that far away from Earth? Well, Yale astronomer Deborah Fisher told Yale News that studying hot Jupiters helps scientists create techniques that can later on help them search for signs of life on other planets.
Scientists now know even more about the 7 Earth-sized planets in the TRAPPIST-1 system. Here is what they found. A new international study led by astrophysicist Eric Agel from the University of Washington and involving scientists from the University of Liège has measured the densities of the 7 Earth-sized planets around TRAPPIST-1 with extreme precision. Scientists now know more about the densities of these planets than any of the other planets outside our solar system, and this provides an important clue as to their compositions. 3 of the system's outer 4 planets lie in the habitable zone, the area around the parent star where a rocky planet is most likely to have liquid water. Although these planets are similar in size to Earth, they orbit much closer to their host star, an ultra-cool red dwarf called TRAPPIST-1 that is only slightly larger, though much more massive, than Jupiter. The TRAPPIST-1 system is located about 40 light-years from Earth in the constellation Aquarius. Both the TRAPPIST-1 system and our solar system lie on the Orion spur between the Perseus and Sagittarius arms of our galaxy. The new study indicates that the 7 planets are remarkably similar in composition and contain roughly the same proportion of materials such as iron, oxygen, magnesium, and silicon that make up our planet. The study found that the planets are all around 8% less dense than Earth. The authors of the study proposed 3 hypotheses to explain why the planets are less dense than Earth. One possibility is that, like Mars, the planets have a rocky surface covered in rust, which is iron oxide. Only unlike Mars, which has a core of unoxidized iron, the iron oxide on these planets would be mixed with other elements all the way to the core of the planets, and the core itself may be oxidized iron. A second possibility is that the planets have a rocky surface with an iron-rich core that is smaller than Earth's. A third possibility is that the planets have a deep ocean layer on their surface and a larger iron-rich core. The third hypothesis is possible for only the outer 4 planets in the TRAPPIST-1 system. If it is correct, then water would account for 5% of their total mass, compared to 1% for Earth. The inner 3 planets are too close to their star for liquid water to exist on their surfaces. However, they could retain water-heavy clouds if they had a dense atmosphere like that of Venus. Scientists say they may have cracked the mystery behind the bright spots on Ceres, salty water that seeps out of the dwarf planet. Here is what they discovered. NASA's Dawn spacecraft shot by the dwarf planet Ceres 2 years ago. After conducting data analysis on the Ocator crater, scientists now say Ceres is an ocean world with brine under the surface. These studies were published separately in Nature Astronomy and Geoscience. Ceres lies in the asteroid belt between Mars and Jupiter. Writing in a news release, NASA says the Dawn mission passed the dwarf planet, and from a distance of about 35 kilometers away, the orbiter took crisp images of Ceres' strangely bright areas and made gravity measurements. From the data, Dawn scientists from the California Institute of Technology determined there is a brine reservoir under the crater's surface, about 40 kilometers deep and hundreds of kilometers wide. The brine consists of sodium chloride bounded with water and ammonium chloride, and the salty liquid is apparently rising to the surface. These compounds are organic chemicals, and the brine also reflects light, which explains the crater's bright areas. Exposed brine could be seen in this false-colored image created by the Dawn science team. Researchers say a meteor impact formed the crater millions of years ago and created fissures that reached the reservoir deep in Ceres' structure. This allows the salty liquids to move up to the surface.
The Kepler spacecraft lifted off on March 6, 2009 from Cape Canaveral. Its mission? To find Earth-like planets. When Kepler retired in 2018, after more than 9.5 years in space, it had observed more than 530,000 stars and discovered more than 2,600 confirmed planets. But not all of these planets are like Earth. In fact, hardly any are. The most common planet observed was between Earth and Neptune in size, a world that does not exist in our solar system. To be considered Earth-like, a planet needs to be similar in size to Earth. It needs to rotate around a sun-like star, and it must be located in a habitable zone, also known as the Goldilocks zone. How many habitable planets did Kepler find? Perhaps as many as 12, NASA reckoned. Add one more to that list. Analyzing old data from Kepler, a team of transatlantic scientists has found that a computer algorithm had misidentified this planet, Kepler 1649c. They detailed their findings in a paper released on April 15th in the Astrophysical Journal Letters. Kepler 1649c is an Earth-sized exoplanet orbiting in its star's habitable zone, 300 light-years from Earth. Kepler 1649c's star is called Kepler 1649, hence the planet's name. Among all the exoplanets discovered by the Kepler spacecraft thus far, Kepler 1649c is most similar to Earth in size and estimated surface temperature. The planet is just 1.06 times the size of Earth, and it may share similar surface temperatures since it receives 75% of the amount of light Earth receives from the Sun, though it orbits a red dwarf star, which may be prone to frequent flare-ups. Kepler 1649c orbits the red dwarf so closely that a year on Kepler 1649c lasts only 19.5 Earth days, but it lies within the star's Goldilocks zone, where temperatures are neither too hot nor too cold for liquid water to exist on the planet. Kepler 1649c has a neighboring planet, Kepler 1649b. Kepler 1649c circles the red dwarf 4 times for every 9 times the inner planet orbits. This 9:4 ratio is rare and may indicate the presence of another planet, which scientists have not observed because it may be too small or have an orbital tilt that makes it hard to find. Scientists are still combing through the vast dataset gathered by the Kepler spacecraft, and they'll probably come across more planets like Kepler 1649c. Astronomers from the University of Canterbury in New Zealand have discovered a new super-Earth orbiting a star located near the Milky Way's galactic bulge, a dense region of stars in the center of our galaxy. This rare super-Earth is 25,000 light-years away. It is one of only a handful among the 4,000 exoplanets to have been detected that is similar to Earth in both size and orbit. According to their research, which was published on May 7th in the Astronomical Journal, the world is 4 times the mass of Earth. It orbits a dim dwarf star that is only 10% the mass of our Sun. This star is so small that the researchers could not determine if it is a low-mass star or a kind of failed star called a brown dwarf. The newly discovered planet orbits at a distance between Venus and Earth from its parent star. But because its star's mass is so small, a year on this world lasts 617 days. To find the planet, the researchers used a method called gravitational microlensing, in which the gravity of large objects bends light coming from other objects. In this case, the super-Earth and its star warped the light from a more distant star. The microlensing effect is rare, with only about 1 in a million stars in the galaxy being affected at any given time, according to the University of Canterbury's news release. Scientists have found evidence of molten iron rain driven by extreme heat on an exoplanet 640 light-years from Earth. Exoplanet WASP 76b is found in the Gemini constellation, where its close orbit to a star causes extreme temperatures on one side of the planet while the other side is cooler. According to Physics World, the conditions are hot enough to break down molecules into atoms on the side exposed to the star. On the darker side, these can recombine into molecules. The exoplanet orbits the star differently to how Earth orbits the Sun. Earth rotates as it circles the Sun. The exoplanet does not. The Guardian reports that, similar to Earth's moon, the exoplanet is tidally locked to the star. This means that only one side of the planet is continually exposed to the star, while the other is locked in darkness. So, if you're suddenly transported there, depending on what side you wind up on, you'll either melt or freeze. It's these conditions that are believed to create the exoplanet's extreme weather conditions and iron rain. And, as if molten metal showers weren't bad enough, WASP 76b is also home to 10,000 mile-per-hour winds and temperatures in excess of 1,000 degrees Celsius.
Scientists have found 2 exoplanets orbiting a red dwarf around 120 light-years from Earth, including a super-Earth. The research published in Astronomy and Astrophysics notes that exoplanets TOI 1266b and TOI 1266c are so close to their star that it takes them just 11 days and 19 days to orbit it. The inner planet TOI 1266b is considered a sub-Neptune as it measures around 2.5 times the Earth's diameter. The outer planet, TOI 1266c, is just over 1.5 times the size of our planet, landing it in the super-Earth category. Both TOI 1266b and c have similar temperatures and are believed to be of similar densities and are comprised of about half of rocky and metallic material and half water, the researchers suggested. This makes them half as rocky as Earth or Venus, but much more rocky than Neptune or Uranus. Their host star, TOI 1266, is a red dwarf. Red dwarfs are the smallest and coolest kind of star, which the researchers note could allow for liquid water to exist even on planets that orbit quite close to them. The outer planet has a temperature similar to that of Venus, even though it is 7 times closer to its star than Venus is to our Sun. The researchers were led by scientists from the University of Bern and the University of Geneva and used the St. X Observatory at the National Astronomical Observatory of Mexico. A press release on the discovery from the University of Bern mentions that the scientists completed their observations shortly before the COVID-19 related lockdown in Mexico. The St. X Observatory remains closed, although scientists hope to resume operations in the next few months. Scientists have discovered a unique rocky super-Earth near one of the oldest stars in the galaxy, according to a statement from the University of California, Riverside. The planet, known as TOI 561b, is located 280 light-years away in part of the Milky Way known as the Galactic Thick Disk. TOI 561b is about 50% larger than Earth and roughly 3 times its mass. The planet is much closer to its star than Earth and orbits twice every Earth day. Life as we know it could not exist on TOI 561b's surface, where the average surface temperature is over 1,726 degrees Celsius, or 3,140 degrees Fahrenheit. Heavy elements such as iron or magnesium that are associated with planet building are less abundant in TOI 561b's region of the galaxy. Scientists believe this is why the planet has density similar to that of our planet. There are two other planets in the system which are too large and not dense enough to be rocky. They orbit a star named for NASA's Transiting Exoplanet Survey satellite. TOI 561 stands for TESS Object of Interest 561. The TESS mission team used the W.M. Keck Observatory in Hawaii to observe the presence of planet TOI 561b. Discovery of planet TOI 561b and observations made about its composition have been accepted for publication in the Astronomical Journal. A newly discovered super-Earth, only 26 light-years away, could offer scientists the best opportunity, thus far, to study the atmosphere of a rocky planet outside our solar system. The star was discovered by a team of astronomers from the Carmenes Consortium. Their results were published on March 4th in the journal Science. The planet, called Gliese 486b, orbits a red dwarf star once every 36 hours. With a surface temperature of 430 degrees Celsius, or 800 degrees Fahrenheit, it is too hot to support life as we know it. 430 degrees Celsius is hot enough to melt lead, and Gliese 486b's hot and dry rocky landscape may be interspersed with rivers of flowing lava. The exoplanet is 30% bigger and almost 3 times heavier than Earth. Its gravitational pull is 70% stronger than Earth's, so a person who weighed 100 pounds on our planet would feel like they weighed 170 pounds on Gliese 486b. Its discovery is significant for 2 reasons. First, it's cool enough to support an atmosphere, but hot enough for that atmosphere to be studied from Earth. Second, scientists can study that atmosphere extensively because it crosses the line of sight between Earth and its star. When Gliese 486b passes in front of its star, the red dwarf's light shines through its atmosphere. When it orbits behind its star, the star's light illuminates the surface of the exoplanet. During both of these phases, astronomers could use spectroscopy, which reveals different compounds according to how they interact with light, to study the composition of its atmosphere. Since its launch in December 2019, Europe's CEOPS Space Telescope has gathered some very interesting information about a very strange planet far outside our solar system. The CEOPS Space Telescope is basically a satellite that orbits 700 kilometers above Earth, and it's packed with sensitive optical equipment. The first extrasolar planet that CEOPS has focused on is called WASP 189b. This planet was first detected in 2018. It's a gas giant like Jupiter, and is situated 322 light-years away. That's more than 3,000 trillion kilometers from Earth. CEOPS found that WASP 189b is about 22,400 kilometers in diameter. That's almost 18 times larger than Earth and 1.6 times larger than Jupiter. At the same time, this large planet orbits much closer to its star. Where it takes Earth 365 days to orbit our Sun, this faraway planet takes only 2.7 Earth days to orbit its huge star. The star around which this exoplanet orbits is bigger and hotter than Earth's Sun. In fact, the star burns so hot that it looks blue. It is 2.4 times bigger and 2,000 degrees Celsius hotter than Earth's Sun. CEOPS also found that the exoplanet's blue star is visibly wider around its equator. That's because it spins so fast that it's being pulled to the outside around its equator, so the star looks a bit oval. The star's poles are also hotter than its cooler equator. Now add the fact that WASP 189b orbits 20 times closer to its hot star than Earth orbits to our cooler Sun, and you can understand why the exoplanet is so incredibly hot. At a surface temperature of 3,200 degrees Celsius, even iron turns to gas on this planet. That's why scientists call it an ultra-hot Jupiter. Hot Jupiters are giant gas planets like Jupiter, but they orbit very close to their stars, making them extremely hot. Another thing that makes this exoplanet very different from the planets in our solar system is the fact that it does not rotate around its star's equator. Instead, its orbit is so extremely tilted that it passes close to the star's poles. Scientists think this must be because the gravity of other planets or stars pulled the planet into its strange orbit. MIT scientists just shot down a popular theory for why lava ocean planets are so bright. Here's what they found. Hot super-Earths are fiery rocket planets orbiting so close to their suns that their surface is heated to lava oceans, and some of those lava worlds, which are roughly Earth-sized, are also extraordinarily bright. According to new research in the Astrophysical Journal, hot super-Earths circle their host stars in 10 days or less, and they reflect 40% to 50% of their star's light. In contrast, Earth reflects only about 10% of the Sun's light. The researchers melted basalt and feldspar at laboratory conditions and then took spectrometer measurements of how much light the substances gave off. The results suggest that lava accounts for only 10% of a hot super-Earth's light. The researchers speculate that lava ocean planets do not owe their brightness to molten lava or cooled glass, as formerly assumed. Instead, the scientists speculate that their brilliance may have originated from metal-rich atmospheres and reflective clouds. First author Zara Asak is cited as saying, "We still have so much to understand about these lava ocean planets." She adds, "We thought of them as just glowing balls of rock, but these planets may have complex systems of surface and atmospheric processes that are quite exotic and not anything we've ever seen before."
For more news animations and explainers, hit the subscribe and bell button to join the TomoNews family. Thanks for watching.